right, let's look at the mass number. So the mass number is another really important value given in the nuclear symbol because it's telling you the mass of that atom. It's telling you exactly what is housed in the nucleus. So remember that the mass number is the number of protons plus the number of neutrons. So you're only dealing with what's in the nucleus. So if I have a nucleus here, and let's say I have 4 protons housed in the nucleus, and I have 1, 2, 3, 4, 5 neutrons, okay, in the nucleus. We can easily determine the mass number of this atom by counting the particles, the subatomic particles in the nucleus. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So its mass number is 10. So that 10 AMUs, and that's the unit we use it in, atomic mass units, that 10 AMUs tells me that that's how much that atom weighs. Now I could even go as far and identify that atom by counting the number of protons. So 1, 2, 3, 4. It has 4 protons, which means its atomic number is 4, telling me that this atom is a beryllium atom. But the mass number is the number of all the subatomic particles housed inside the nucleus. We do not use the electrons to determine the mass because remember, the electron is so small in comparison to protons and neutrons that it doesn't affect the mass significantly. So we kind of tend to ignore the mass on an electron. So we place the mass number on the top of our symbol, and the thing you need to know is not all atoms of the same element are going to have the same mass. So this is what we call an isotope. So they are going to differ in the mass, but they're still going to be the same element. So let's take a look at what the example here is we have with carbon. So we have an atom of carbon with the mass number of 12. So we obviously have 6 protons, right, because of this number here. And neutrons we can easily determine because we take the 12 minus the 6, so we have 6 neutrons in that particular carbon atom. In the other one, we have a mass number of 14. So it has a heavier nucleus than its counterpartner there of carbon 12. So I know here, again, because it's carbon, it has 6 protons. And we can determine the neutrons by taking the 14 minus the 6, and we're left with 8. So this particular carbon atom, carbon 14, has 8 neutrons. And because of that difference, we call them isotopes. All right, isotopes are when you have the different nuclear weight, so a different mass number, because your neutrons are going to vary. You can have more, you can have less.